All right, today we're going to solve problems involving probabilities. So as you can see here, we have three types of exotic pets. The first one is tarantulas. So we can let T equals tarantulas, and there are 78 people. And 81 people own chinchillas. So let's C equals chinchillas. Okay, so there are 81. And P equals potbelly pigs. We have 63 all in all. And as mentioned here, we have 46 people own chinchillas and tarantulas. Okay, so here we're going to have 46 equals C intersection T, because and here is intersection. All right, so 46 equals C intersection T, that is mentioned in the problem. 46 people own chinchillas and tarantulas, and 62 people own exactly two of these exotic pets. So 62 equals exactly 2. It means C and T only. Okay. Plus, so we have to mention here the word only. C and P only. Plus P and T only. Okay, so that's the meaning of exactly 2. So we have C and T only, or T and C only. And we have C and P only, and T and P or P and T only. And the total is 62. 31 people own tarantulas and potbelly pigs. So you can write it here. 31 equals T and P. And 16 people own tarantulas, chinchillas, and potbelly pigs. So this 16 is the intersection of three exotic pets. So 16 equals T and C and P. So we are going to use a Venn diagram to answer the questions here. We have three questions. So we have the information already. The technique is when you're reading the problem, take note of the details immediately, like what I did here. Okay, so one by one, you're going to take note of the details. Sentence by sentence, you are transforming into values. So define the variables and take note of the details such as intersections. Okay, so let's now have our Venn diagram. Usually we put these element symbol outside. We have three sets. The first contains tarantulas, that's our T, and C is our chinchillas, and the last is P, the potbelly pigs. You can search about the images of these animals or pets in the internet for you to know what are these exotic pets. So we have T, C, and P as our sets. So let's now complete our diagram by putting the values here in every section. So usually what we're going to do is to start in the middlemost area. or section. So we're going to start from here, and that is, of course, the 16, the intersection of T and C and P. So you can use this symbol or you can use the intersection. This is the AND. Okay, so 16 is the intersection of three sets. So it's gonna be here. And let's slowly move out. So let's start with 46, that is equal to C and T. So that is the intersection between these two sets. So basically, C intersection T is here. This is our C and this is our T. So that is the whole intersection, including 16. So including 16, the total there is 46. So this section is going to be 46 minus 16. So the answer here is 30. So this is 46 minus 16 because the total there should be 46. All right, so we are slowly moving out. The next is 31. Okay, 31 is T intersection P. That's this section. This is our T and this is our P. So that includes 16. So 16 until here should be 31. So this section is 31 minus 16. So it's gonna be 15 here. Okay, so this is again 31 minus 16, which is equal to 15. Okay, so let's now have this area or this section. Okay, we are done with 16, it's here, and we are done with 31, that's 15 plus 16, and we are done with 46, that is 30 plus 16. Now let's proceed to 62, which is exactly 2. That is C intersection T only. So it means 30 plus this area, C and P only. So we can put this as X, okay? Because we don't have the value there. And we have P intersection T only, which is 15. So to calculate or to solve for X, we have to add all of this, which is equal to 62. So 62 is equal to 30 plus 15 plus X. So this 13, 15, and X, that is exactly 2 there because 30 here is exactly T and C or C and T. 15 is exactly T and P, and X is exactly C and P. So these are the sections for exactly 2. We have 3 sections there, 30, 15, and X. So we have to combine these 3 sections. So basically this will become 62 equals 45 plus X. Transfer 45. It's going to be negative 45. So X is equal to 17. That's 62 minus 45. So this is 17 here. And now we can get the values here. This section is T only. This is C only, and this is P only. We have the values of every variable. We have T is 78. So this area is 78 minus 30 minus 16 minus 15. So the answer there is 17. So if we're going to add these values, 17 plus 30 plus 15 plus 16, the answer is exactly 78 because this is 47 plus 16, 63 plus 15 equals 78. Now for C, the total is 81. So this is C only area. So this is 81 minus 30 minus 16 minus 17. The answer there is 18. So 18 plus 30 is 48 plus 16. This is 64 plus 17. It's 81 exactly. So the last is P only. The total is 63. 63 minus 15 minus 16 minus 17. That is 15 there. So if we're going to combine, we have 15 plus 15, 30, and plus 16, 46 plus 17, that is 63 all in all. Okay, so the first question is, how many people do not own tarantulas, chinchillas, or potbelly pigs? And calculate also its probability. So the total number of exotic pet owners is 230 all in all. So what we're going to do, we're going to subtract all of this from 230. So 230 minus the sum of all of this. So minus 17 plus 30 plus 15 plus 16 plus 18 plus 17 plus 15. Okay, so to get the number outside, that is 230 minus the sum of all, minus all the sets. Okay, so all the values inside the circles. Okay, so the answer is 230 minus all of this. The answer is 102. So we're going to put 102 here. So that's outside. Okay, so let's calculate the probability of this. That is 102 all over 230. So the answer for A, I'm going to put the answer here. This is 102. So that means the total here is 128. 17 plus 30 plus 18. So 17 plus 30 plus 18 plus 15 plus 16 plus 15 plus 17. This is 128. Because 128 plus 102 is 230. Okay, so the total here outside is 102. So the probability here equals 230 is the total. So 102 over 230. That's going to be 0.4434 multiplied by 100. That is equal to 44.34%. Okay, so that's the answer for letter A. So let's proceed to the letter B. Let me take a screenshot of this. Okay. So we can have more space. Okay, let me put the answer here. I answered already letter A. Let's proceed to letter B. Letter B is already given how many people own potbelly pigs, but we have to calculate the probability. So P is equal to 63 here. Okay. So the probability here equals 63 over 230. The answer is 0.2739 times 100. That is 27.39%. Okay, so that's 27.39%. For letter C, This is how many people only own chinchillas. So only C. Only C, we have 18, this area. And the probability equals 18 over 230. This is 0.0782 or 7.82%. So we multiply by 100. So this is how to answer this particular question. It's simple actually, but it's a bit, longer. All right, so let's proceed to the next. Here, what we're going to do, this is very similar to this. In this problem, we completed our diagram by putting all the numbers of exotic pet owners. So you can see here, these are number of people owning these exotic pets. Okay, so what we're going to do here is very similar actually. Instead of numbers, we're going to put the probabilities because the given values are probabilities. Here, the given values are numbers. Basically, this one can be converted to probabilities. What we're going to do is to divide every number by the total. For example, this one 17 over 230. This will become a decimal here. 30 over 230, that is going to be a decimal, and so on and so forth. So these problems are very similar. The only difference is that here we have numbers. Here we have probabilities in decimals. So there are three sets here. The first is set of engineering students. So this is the college dashboard, talking about engineering, business, and information technology. So the variables are already defined. We have E for engineering, B for business, and T for IT. The expected numbers of randomly selected students with respect to these courses are provided below. And we have to draw a complete Venn diagram to specify all of these probabilities. So it's very clear. We have three sets of students: engineering students, we have business students, and IT students. So we're going to have here our universal set, the whole rectangle containing three sets. We have three students. Okay, we have EBT. So this is engineering. That's E. This is for business students, and we have IT, information technology students. So draw the circles and label them according to the variables given or the variables that you have defined. Okay, so let's start with the intersection of three sets. This E intersection B intersection T. So we start from here. That is 0.07. Then we slowly go out. Okay, so let's have the intersection. E intersection B is 0.1. 0.1 actually is not 1. This is 0.10. Okay, it's different from 0.01. So please be careful of the values. This means 0.10 or 0.100, or you can add 3 or more zeros on the right. So E intersection B, that includes 0.07. So here, this is going to be 0.1 minus 0.07. So the answer here is 0.03. So this is 0.1 minus 0.07. Okay, because the total should be 0.1. If you're going to add this two, if you're going to add 0.03 plus 0.07, the answer is 0.1. or 0.10. Okay, so slowly we are trying to complete our diagram. Let's proceed to B and T, or B intersection T, that's 0.2 or 0.20. So it's this section here, but we have already here 0.07. So this is 0.20 minus 0.07. So the answer here is 0.13. If we're going to add both of these values, 0.07 and this, the answer is 0.2. Okay. Next is for E intersection T, this section here, okay, including 0.07. So this section here should be 0.14 minus this. So the answer is 0.07. So if you're going to add both of these, the answer is 0.14. So the remaining are only this, E only, B only, T only, and outside. So we have here the total for E, 0.19. So 0.19 minus these values, minus 0.03, minus 0.07, minus 0.07. The remaining here is 0.02. So if you add all of these, the total is 0.19. For B, this is B only. The total is 0.3 minus 0.03 minus 0.07 minus 0.13. So the answer here is 0.07. And for the last, for our T is 0.4 minus all of this, minus 0.07, minus 0.07, minus 0.13. The remaining is 0.13. So that's complete. Now, we don't have the total number of students here, and we are given the probabilities. Based on the law, the total probability is 1, or should be 1. So 1 minus all, 1 minus the sum of all. Okay, so you have to add all of this. The answer is 0.48. Because if you're going to add all of these from 0.02 until here, that's 0.52. So 1 minus 0.52, the sum of the numbers inside the circles is equal to 0.48. So here we have to put 0.48 or 0.48. Okay, so we just put this one exactly inside, or we can put it here. This is our complete diagram. Okay, so let's proceed to the next question. Okay, in a particular city, we have 70% of the households use the local power company for electricity, and 65% use the same company for water supply. So the both here, or intersection, is 45%. 45% of households use the company for both electricity and water services. If a household is selected at random, what's the meaning of at random? At random means we don't know which one is really going to happen. That's the meaning of at random. We know it's going to happen, but we are not cheating. For example, if we have a box of, where we have the names of the students, we're going to mix all of the names of the students written in paper, for example, and we have to pick one from this box. So that is at random. We don't look at it. We mix all. So we don't know exactly which one is going to be selected. That's the meaning of at random. It is uncertain. So we are not sure which one is going to be picked. So what is the probability that it uses at least one? So we're going to pick one household or one family, okay, at random. What is the probability that it uses at least one of these two services, electricity or water? So the keyword here is or. So at least one means union. So please remember that. At least one means union. In our propositional logic, as you can see, we have T or, because or is union, is true. True or false is true. False or true is true. False or false is false. So these are at least one. Here, at least one means one or more. So here we have 1T, it is true. Here we have 1T, it's true. And here we have 2T's. It's also at least one because it's one or more. Here we have 2T's is also true. Of course, here we don't have T, it is false. So at least one true is gonna be true. So it's about union or. Okay, so we can use the union principle here. So we have two sets. First is electricity. Electricity is 70%. Okay, this is for the electricity. And for the water, we can have W, that is 65%. And 45%, this is for both. It means E intersection W equals 45%. So it means that this one here is 45%. So to calculate for the probability that it uses at least one of these two services, electricity or water. So we have for letter A, here we have P of E or W. So the formula is P of E plus P of W minus P of E intersection W. Okay. So the intersection is here in the middle, 45%. So we have 70% plus 65% and minus 45%. So the answer is 90%. So here the answer is 90% or 0.9. All right, so I hope that's very clear. Now for letter B, what is the probability that it uses exactly one of the two services from the company? Exactly one is exclusive or. This means exclusive or we call this as the ring sum. The symbol is this. Okay, so let me transfer this. All right, so for this, it is exclusive or. So if you have two sets, for example, this is our E and this is our water here. Okay, electricity and water. We have true, exclusive or true is false. True, exclusive or false is true. So exactly one. Of course, false, exclusive or false is false. So only two here. This is the meaning of exactly one here. So it is exclusive or. because here we have T and then we have F, so exactly 1T. So the first column is for electricity, so it means electricity only. And here we have F, exclusive or T. So the first column is electricity, second column is, this is electricity, second column is water. So the second one here is water only. This is electricity only. So electricity only is here, right? So the total therefore is 70%. So this area would be 70% minus 45%. So the answer here is 25%. And for this area, the total for water is 65%. So 65% minus 45%, that is 20%. So 25% is for electricity only, and 20% is for water only. So the answer for B exactly 1. We have to add 25% and 20%. The answer is 45% or 0.445. Okay, so that's how to answer this question. It's very simple actually. Um, we use here the propositional logic principles. That is why propositional logic principles are very, very important. The truth values, because these are linked to probabilities and it's linked to sets as well. Okay, so that's it. Let's proceed to the next here. This one is about inclusive or. So it's very simple. Here the keyword is or. Either or is inclusive or. And here we have at least one. Again, this is inclusive or union. Okay. So whenever you see these words either or at least one, this talks about union or inclusive or. Union is inclusive or. It's equal to this symbol. This is or we call this as inclusive or, because including both, as you can see here, including both. True or true equals true. That's why we call this as inclusive or. All right, so the first one is about the cloud infrastructure project. That is your C1. So we can label this as C1. Okay, it's given here. We have 3 major technology projects. C1 is for the cloud infrastructure. C2 is software development project. C3 is about cybersecurity upgrade project. So it's defined already at the beginning. So the software development project, this one is C2. So easily we can now generate our formulas. So for A, we have P, C1, union or C2. It's mentioned here. So C1 or C2, when we have the or there, that is P of C1 plus P of C2 minus the intersection. So please remember this formula. This could be A or B. So the original formula is P of A or B. This is equal to P of A plus P of B minus the both, the intersection. So instead of A or B here, we use C1 or C2. Okay, so it's similar. So the values are given here already. So we have C1, that's 0.26. C2 is 0.30 minus C1 intersection C2, 0.12. So the answer is 0.44 or 44%. Right, so That's our answer there. Now for letter B, at least one of the three projects. So at least one again is union or. But here we have three projects, C1, C2, and C3. Okay, so let's try to have the answer on the next slide. Or I can make it like this. Okay, for the letter B, that is for P, C1 union C2, union C3, or you can put or here. This is because of these words, at least one. So that is P of C1. You combine all, and then the intersection. Subtract all this intersection. So we can put it like this, minus directly P of C1 intersection C2 minus P of C1 intersection C3 minus P of C2 intersection C3, then plus the intersection of these three. So these values are given already. So we can just plug in the values. We have 0.26 plus 0.30, 0.35 minus 0.12, 0.08, 0.10 plus 0.03, answer 0.64 or 64%. So it's very simple. Just combine all C1, C2, C3 minus all the intersections and plus the intersection of three sets. So that's how to answer this. It's very simple. Let's proceed to the next. Here, two dice are rolled. What is the probability that the sum of the outcomes is greater than 7? Now, this table is not given. This is the all-in-all sample space, the universal set when we have two dice. For one die, we have 6 possible outcomes. So the formula is 6 raised to the power of n. N is the number of dice. If you have two dice, for example, plural, this is 6 squared. The answer is 36. So 36 possible outcomes. If you have 3, 216 possible outcomes. Usually, we have 2 or 1 possible outcome. So the highest sum is 12. That is 6 plus 6. And the lowest sum is 2. That is 1 plus 1. And this one is in any order. It could be 1, 2, or 2, 1. That's for 3. There are 2 ordered pairs there. So these are the numbers. For 4, we have 2 plus 2, 3 plus 1, 1 plus 3. We're getting the combinations from here. Okay, so in any order for your test. But you are not supposed to draw or to create this table in the exam. You have to look at the condition. What is the question? Greater than 7, so you have to start from 8 only. So I'm just explaining this for you to see all the possibilities, but you're not supposed to create this table on the test. You have to look at the condition. Here we have greater than 7. I might say at most 5. If I'm going to say at most 5, so you have to look at only 2, 3, 4, and 5 as the sum and the number. So from 2 to 7 minus 1. So the number is minus 1. So this is 1, 2, 3, and 4. So very simple. Then after that, go down. So 5, 4, 3, 2, and 1. So as I said, these pairs here are in any order. So you can start from 6, 1, and then 1, 6, and so on. Write all the possibilities from 1 to 6, getting the sums. Okay, so the question is only greater than 7. So we are going to have sum from 8 and start from down. So 1 go up, 1, 2, 3, 4, 5. So if it is, above 7 or from 7, then you can start from 1, then go up. So you'll not be confused. If the numbers are lower, like at most 5, at most 6, at most 7, you start from up going down by subtracting. Of course, you have to stop at 6 and then go down to 5 and so on until 1. So this is the table for this particular question. 8, we have 2 plus 6, 6 plus 2, 5 plus 3, 3 plus 5, 4 plus 4 in any order. 9 is 6 plus 3, 3 plus 6, and 4 plus 5, like 5 plus 4. And then here, 4, 10, 4, 11, and 4, 12. And count all. Okay, so the P greater than 7 equals 5 plus 4 plus 2 plus 1 over 36 all in all. So 15 over 36, 0.41666. Okay, so you can use your calculator. So times 100, that's gonna be 41.67. You can round it off to 2 decimal places. Okay, so that's all for this particular session. Thank you so much for watching. Until the next time, bye-bye.